Example 7, why does the lion's hair stand on end? What does that tell you about the lion's body? So first thing, why does the lion's hair stand on end? What's happening to the lion as he touches the Van de Graaff generator? Sergio?
Yes.
What?
Yes. Yeah.
What happens?
Well, because the electrons have gone to the body and try to make their way out. And so that's why the hair is on foot, because that's the electrons trying to make their way out of the body.
Perfect. So the electrons are coming up to the Van de Graaff generator, leaving the Van de Graaff generator, traveling through the lion's body, and getting as far away from each other as possible, like Sergio said, puts the hair staying on end because the electrons are pushing each other apart.
True.
So his hair stands on end. Those electrons are trying to escape one another. Now, if the lion gets too much charge, what's going to happen to the lion?
His head will explode.
No, his head won't explode. Okay. The electrons will start to jump, just like lightning bolts jump from clouds. Okay? So that's one of the issues why it's nice that it was kind of humid yesterday, because we were about getting shocked about it.
So,
yes.
lightning, is that like just pure electrons?
Pure electrons. So what happens is the clouds gain a lot of electrons because falling rain. Rain is a charged particle. The water in the rain is a charged particle. Okay, that water can either ionize or it can just attract electrons because water is polar, gentlemen. Because water is polar. When the water falls, friction takes electrons off of the water molecules. The electrons then stay in the cloud because that's where the most friction is at, because of the densest parts of the sky. The clouds then store those electrons. When those electrons build up or get too much, then the electrons don't like being by each other. They'll try to jump. So they'll jump to a nearby cloud that might have a smaller charge as you get lightning through the sky. Or the cloud's close enough to the ground or close enough to a tree or a building, the lightning will jump to the tree or to the building. Or to the ground. And that's just electrons, too much electrons in the cloud, then jumping down. And like the little clicks we heard with the Van de Graaff generator, you know, like when we lit the lights and made a little click noise, that's thunder. But since there's such a small amount of electrons jumping, the thunder's not that loud. Yes?
Did you hear about this? Like a lightning bolt hit the school and the students got shot.
Really?
Was it like, yeah, there were a couple waiting on the lockers who got burns on their back.
Wow. Must have a grounding issue then. Because that shouldn't happen. There should be wires that go from the roof to the ground, so that the electricity transfer through. All right. Why does this say about the lion? So the fact that there's electrons that are going through his body, what does that say about the lion?
He's getting some load.
No, he's a what, Richard?
Insulator.
No!
Conductor.
Conductor. He's allowing electrons to move. He's a conductor. Lions, like humans, are mammals. All mammals are conductors. So be careful around electricity. 8. How does a balloon that holds a static charge stick to the wall? What do you guys think?
Because the wall has a neutral charge,
Good.
and so it likes to stay there.
So it likes to stay there.
Well, the electrons inside the thing, will they charge?
Because the balloon is charged.
Either one of them.
And the wall.
Okay.
Either positive or negative, just like this.
Balloon.
Can you put the string to it?
You have balloon on hair. The balloon likes electrons. So the balloon will get some negative charge. Okay? So there's a lot of negatives, some positives, right? Now when I bring said balloon towards wall, the wall is neutrally charged or grounded. Okay? But the wall contains positive and negative charges, right?
Yes.
As the balloon approaches the wall, what happens to these negatives? They move. They don't like the balloon. So the negatives will move away. So then what the balloon, air quotes, sees, balloons don't have eyes, alright? But what the balloon feels is a strong positive charge that's closer than the negative charges, right? You guys see that? So when the balloon is up against the wall, the negatives and positives are attracted to one another, so the balloon will stay there. Okay?
Sounds like a magnet.
Does that make sense?
Yes.
Right.
Richard, what's the question?
How do they move?
It's a solid. Well, even if it's an insulator, the electrons can still wiggle a little bit, so they'll get as far away from the balloon as possible, as far as the material will let them move.
Is that why the water
Well, it depends on what the wall is made of, but yes, that's why the balloon doesn't stick to the wall as well. And if the wall's a 100% conductor, once the balloon touches it, electrons are running off that balloon.
So if it was
So it'll lose charge.
the metal wall, it would just stay there.
No, because the metal wall, you touch it and you're done. Because the balloons would come off the other. Every part where the balloon's touching the wall, the electrons would leave. Because the metal's a conductor.
It was a solid wall.
The drywall is an insulator, so it works better on insulators.
So you need an insulator for it.
It works better on insulators. Okay. Now, why might humidity, like we have right now, which is why we're not going to do this demonstration because the balloon will just fall. Okay. Why might humidity play a role in this? Water's conductor, good. So when you have humidity, there's lots of water in the air, right? So when those water molecules bump into the balloon, what do they take from the balloon? The electrons. Okay? Gives the electrons a way out. Right. Example 9. What is the difference between charging by conduction and charging by induction? What type is the line experiencing? Good. The line is experiencing conduction because he's touching the electroscope, or not the electroscope, the Van de Graaff generator, right? Induction, Sergio and Kevin, and Maria. Kevin. Thank you, Sergio. Okay. Induction means it's by not touching, right? If the lion was holding his hands around the Van de Graaff generator but wasn't touching it, and this other little lion grabbed onto that lion's tail, okay, what would happen is the negative charges in the lion would have an outlet to get it farther away. So the negative charges in the lion would go to the little lion if he's holding his tail. Gives those negative charges a way to go. So the lion wouldn't be touching the generator. The negative charge would have some place to go. So if this was induction, the lion would get a positive charge. Now that is very dangerous given this Van de Graaff generator is quite large. Because if the lion has a strong positive charge by induction, then that means the electrons in the Van de Graaff are attracted to it. Can you guys picture what might happen?
A miniature lightning bolt?
Miniature lightning bolt. Painful, probably. Okay. Kevin, how come birds? We can sit on them. Okay. The problem with us is getting on the electrical wire. Okay. Because if I'm going to get on the wire, I'm going to need to climb a ladder, right? I can't just fall from the sky and land on the wire. Okay. If I jump out of something, I might touch 2 wires. If I touch 2 wires, that's an issue. Okay. If you touch 2 wires, now you have electricity from one wire going to the other, passing through your body. It doesn't feel very good. If the birds, they just sit on the wire, they're only touching 1 wire, so they're not conducting they're not letting electrons conduct anywhere. Okay, it's not like a lightning bolt then. But if you touch 2 wires, then it'll be like a small lightning bolt going through your body, or a big lightning bolt. Or if you come from the ground up, then the electricity in the wire is going to come down through you and move to the ground. But if you just get dropped right on the wire, 1 wire like the birds can do, then there's no worry about the lightning bolts. It actually warms the birds up because when the birds, it's kind of like rubbing your hands down. When the birds stand on the wire, the electrons passing by, there's some friction there, and that heats the wires up and heats the birds up. That's why they sit on it, to make them warmer. Eric?
What happens when lightning strikes the car?
When lightning strikes a car?
Yeah, would it go straight to the ground? Or?
It can because there's a lot of charge in lightning. So it could just bypass the tires and jump to the ground. Okay? But if like an electrical wire falls on the car, there's not as much electrons as in when you have a lightning bolt. So if you get out of a car that has an electrical wire that fell on it, then you're providing a quicker pathway for the electrons to get to the ground. So that's actually dangerous. So if you're in a car accident and an electrical wire falls in your car, stay in your car. Unless your car's on fire, and then you gotta.
They say like jump out as far as possible.
Yeah, try to go out without touching anything. So open the door, and then try to jump out of the car without touching the metal.
Or don't touch the ground.
Right. Try to get out of the car without touching the ground or metal at the same time.
Without touching the ground?
Or the metal at the same time.
Or the metal? How do you get out of the car without touching the
You
ground?
jump.
Like, you eventually touch the ground.
Right, but you won't be touching the metal. You'll be far away from the metal at the same time you touch the ground. Okay. All right. Any other questions? Questions are wonderful.
Wow.
That's fine.